There's two ways that I can prevent erosion or preserve the die. Basically, I want to try the die out and get it to where it's making an acceptable strain state within the part. And then I want to lock the die down. I want to freeze it so that no more change to the shape happens, no more change to the geometry. So I can add a surface coating, much like for the low mild steels, chroming is a typical process that we're utilizing now, very, very common among the big three. Also, we can have what's called vapor depositing, which if you think about drills and in mills, if you've seen any that have like a gold coating, that's a titanium nitriding. They also have some other additional coatings where they're basically a blue color or almost a purple color, several different additives, aluminum, titanium nitriding, and that sort of thing. But basically, these are a very, very thin coating. They're only a half to 1/1000th thick. Some of the vapor deposited coatings are only 2/10,000ths of an inch thick, so there's no opportunity to grind on them. But what they do bring to the die is a very, very hard wear-resistant surface that also does a great job of reflecting or transferring the polish from the underside, whatever the die is polished to. These will mirror that polished finish. So I can polish the die very, very substantially, give it a nice mirror finish, put on one of these coatings, and preserve that shape for a long period of time. The other option is to actually physically change the chemistry of the die component through either when I started, we did a lot of cast steels and high grade cast irons with very, very consistent carbon content. And we could literally take a torch, heat them up to a specific critical temperature, and right behind the heating system, have a quenching system. So we heated it up fast, we quenched it, and we took the ferrite and put it into, if you remember what Craig talked about with the face-centered cubic, literally changed the crystal structure of the material and gave it a very, very hard wear-resistant surface. Then you could polish that down a little bit, return the low coefficient of friction to the die, and have a very wearable, durable surface. With the new lower quality cast irons and cheaper cast irons that are being utilized, they don't flame harden or heat harden in a consistent manner. So they've come up with this thing called ion nitriding. Basically, it's done through a furnace. The die is put into a furnace. The die, I believe, is charged negatively. The atmosphere is charged positively. All of the oxygen and that is evacuated from the chamber, and pure nitrogen is put into the chamber so to prevent rusting. As the current increases, the nitrogen becomes electrically excited, bombards the surface of the die, and actually creates an iron nitrogen alloy. Again, it might only be 6 to 8 thousandths of a depth, but it is a very, very hard, durable surface, and it gives them a little bit more wearability than a thin half-thousandths thick chrome layer. So it is a little bit more durable. Because of the length of time, typically chrome plating, they can chrome the die and get it back to you in maybe as little as 24 to 36 hours. With the ion nitriding, because you have to slowly bring it up to temperature, hold it for a period of time in the oven to allow the penetration of the nitrogen ions, and then slowly cool it back down so we don't end up with thermal fracturing or warping. It might be a 3 or 4 day process in order to get a die back. Also, you have their equipment tied up for a longer period of time. So ion nitriding, although it is more durable, is also more cost prohibitive. It's probably 2 to 3 times the cost of chroming a die, but it definitely does give you a very long-lasting, durable finish also. These are chroming alternatives. If in fact some of these high-strength materials that we're starting to use, I don't get the durability out of the underlying cast iron, so we may actually start to utilize machine tool steels, in which case those inserts or those sections of the dies can actually be put into a heat treating oven and get a much deeper case. Advanced high strength steels, and this is basically recommendations from the World Auto Steels and Auto Steel Partnership. They're talking about for forming and flanging dies. Typically, we're going to want to have for materials that are up to 590 megapascals, you're going to want to have like an iron nitrided base with some sort of a physical vapor deposited like chromium nitride coating. You could be iron nitrided with titanium nitriding or some other type of material. For materials of 780 or higher, they're talking about iron nitriding with chromium nitride plus. I believe the MOST is a particular trade name of a process for coating. For restrike dies and for like other forming dies, again, kind of about the same applications. Chromium nitride over a vapor iron nitrided material, or chromium nitrided in a MOST coating for materials above 780 megapascals is recommended.